The fact the inverse image and the push forward from an adjoint pair has important corollary. And we will see stalk and skyscraper from an adjoint pair too, as a special case. Let's take the topological space X to be a one-point space where this point is taken from the space Y. And let S sub P to be an embedding of this point to Y. And now let's compute S sub P pre inverse G of U, where U is an open subset of this one-point space P. There are only two choices for U. Either it is a whole space, the one-point set P, or it is empty. By definition, this is a colimit. And this colimit is also very simple. If U is indeed the one-point set P, then we will get stalk of G at P, because this is really the definition of stalk. However, if U is empty, we will get the G of an empty set. But this is a one-point set. From here, you can immediately see that this IP pre-inverse of G is already a sheaf. So it is automatically equal to its sheafification. Therefore, for this special embedding, we can identify the inverse image of a sheaf on Y and this embedding with the stalk of this sheaf at this point. Since the inverse image and the push forward form an adjoint pair, there's a one-one correspondence between the sheaf maps from the inverse image sheaf to a constant sheaf at S, and the sheaf maps this sheaf G to the push forward sheaf of the constant sheaf at S under this trivial embedding. The first set can be identified with the set of maps from the stalk of G at P to S. The second set can be identified with the set of the sheaf morphisms from G to the skyscraper sheaf at P with respect to S, where S is a set defining this constant sheaf. This is because the push forward of a constant sheaf can always be identified with the skyscraper sheaf with respect to the set defining this constant sheaf. This is by 2.2.12 of Professor Vakil's book. Therefore, the maps from the stalk GP to a set S are the same as the maps of sheaves on Y from G to a skyscraper sheaf with set S supported at P. This remark is also very useful. And now let's see two of its applications. First, let's see the sheafification induces isomorphism between stalks. We are going to prove if there's a sheafification, then there's an induced isomorphism between the stalk of G at P and the stalk of its sheafification at P for any P in Y. Here we are taking G as a sheaf on Y. According to our remark, we have the following identification. Here, the sheafification of G is playing the role of G in our remark. Recall that the sheafification is left adjoint to the forgettable functor. This is by 2.4.L, and this forgettable functor sets the sheaf to its pre-sheaf. So, the set of maps from the stalk of the sheafification of G to S is isomorphic to the set of pre-sheaf maps from G to the skyscaper pre-sheaf. But on the other hand, the same proof I've seen here shows that the pre-sheaf stalk is also adjoint to the skyscraper. By the uniqueness of the left adjoint, we have the pre-sheaf stalk at P is isomorphic to the stalk of the sheafification at P. So we have the sheafification induces a isomorphism between stalks. And this is actually his 0.4.M. Now let's look at the second application. We will prove the following two statements are equivalent. So the phi is an epimorphism in the category of sheaves is equivalent to saying that it is surjective on the level of stalks. The relatively easier direction is from 2 to 1. Suppose we have a sheaf morphism from the sheaf F to sheaf G and two sheaf morphisms from G to H, such that P precomposed with psi 1 is equal to the phi precomposed with psi 2. Then we look at this at the level of stalk. At the level of stalk, this equation always holds true for any point in the topological space X. Since psi is surjective on the level of stalk, so we can cancel psi of P from both sides of this equation. And we get, at the level of stalk, psi 1 is equal to psi 2 for any P in the topological space. And now by 2.4.D, this is an exercise in the 2.4 section. We have psi 1 equal to psi 2. Therefore, phi is the epimorphism in the category of sheaves by definition. Now let's show the opposite direction is also true. Let phi from sheaf F to sheaf G be a sheaf epimorphism. We want to show that it induces surjection at the level of stalks. To this end, we take an arbitrary set S and two maps G1 and G2 from G sub P to S, such that G1 composed with phi sub P is equal to G2 composed with phi sub P. We want to show that G1 is equal to G2. and we wish to use the condition that phi from F to G is a sheaf epimorphism. In other words, specifically, if we have this diagram, we want to lift this to the level of sheaves. The set S will be lifted to the skyscraper of S supported at P. Because if you take the stalk of this skyscraper sheaf at P, you get the set S. We hope we can find two corresponding maps of G1 and G2 respectively. To this end, we use the results in here. We notice that there's a natural bijection, and G1 and G2 are maps in here, which corresponds to two maps in here. Now we claim that G1 tilde composed with phi is equal to G2 tilde composed with phi. And if this claim is true, then by the fact that phi is an epimorphism, we have G1 tilde equal to G2 tilde. And back to the level of stalks, G1 will be equal to G2. To prove this claim, we look at the following diagram. This is a diagram associated to the naturality of this bijection. From this diagram, we know the phi star composed with tau of Gi is equal to tau composed with phi sub p star of G sub I for I equal to 1 and 2. The left hand side is equal to G sub I tilde composed with phi, because tau of G sub I is G sub I tilde by our definition. And the right hand side is equal to tau of G sub I composed with phi sub p. And now, since G1 composed with psi sub p is equal to G2 composed with psi sub p, this is our assumption. We have G1 tilde composed with phi is equal to G2 tilde composed with phi. And now, since phi is an epimorphism, we have G1 tilde equal to G2 tilde. And by taking stalk at P, we get G1 equal to G2. And we are done.